Hello, Dr. P, and my dear classmates. Hope you all safe and doing great in this sketchy time. Today, I am going to present my last presentation of academic as I am graduating. The topic I am going to talk about today is on effect of climate change on crop-pest relationship, which connects with both our course and my country as well. The concept and the papers I am going to talk about are concerning crop, pest, and how both relate to each other and to climate change in general. Let's begin, shall we? It is predicted that in the next 30 years, there will be a major shift in the crop yield due to the climate change. As you can see on the top right, Gorna et al. Claims there is likely to be a negative shift of varying magnitude depending on the climate region, which is also said to be made worse if we fight climate change. Why? According to NASA, the reason behind this is the fact that crop might experience higher yield due to the increased level of carbon dioxide that stimulate increase in the rate of photosynthesis. The effect can be both short-term and long-term, and can be seen on graph C and D that wheat can not able to adjust to rising temperatures, unlike rice on graph E and F. Is temperature the only symmetric variation able to affect crop yields? Ray et al. Indicated that corn also showed remarkable adaptation to the new climatic condition by shifting that productivity to new climatic region. As you can see on the productivity distribution graph, basically it now grows better where it grew poorer in the past. When you add the yield losses and gains together across all regions for this crop, the number is positive, meaning that climate change didn't make a difference on this major food crop along with rice, but affected others. Darker areas are the area of worsening yield. He also pointed out that wheat failed to regain positive productivity over time across the globe, but the pattern seems to be different from that of corn and rice. As you can see on the graph, is it more temperature sensitivity or are there other climatic effects responsible for such change? According to the Fourth National Climate Assessment, extreme one-day precipitation poses risk to crop yields because there is a higher chance of land erosion and loss of water quality. As a result, abnormal land compression and consolidation will take place. Upon continuous agricultural operation under this condition, yielding poor soil quality. On the top right, you can see a reported increase in the land area being affected by such precipitation, and that is just in the USA. On the bottom two graph, there is a clear-cut differences in precipitation ranks across the state for the past 2 years. But is that the only factor that can affect productivity in other part of the world? In his research letter, Ram L. Ray stated that across different climatic zones in Texas, unsurprisingly, there will be a decrease in crop yield if periods of drought will be longer than usual. Here on the graph, corn shows its adaptation once again in the contrast with the wheat, assuming enough moisture is being supplied using under groundwater. The problem is drip irrigation is expensive and the level of groundwater will not always stay the same if constantly drained. It is now unsurprisingly that corn grows in a region where there is more precipitation. But what does it mean if the population is bothered by pests? Here it is no longer a singular problem, but rather a multivariable one, where pests can go along with the primary climatic effects. Moving to the next slide, the influence of pest on crop under hectic climatic condition wasn't studied as much, but cases are reported in the past. such as those mentioned by Krishnan et al. In his research work. India's crop productivity is not the best comparing to Sri Lanka, but it covers a huge area of land and the country cannot afford a let pest diminish already climate affected major crop is. India's crop outcome could be a good opportunity for studying multivariable crop relationship, especially with Sesamia influenza, which you can see on the right in its adult and larva form. So what would be the relationship between its pest-ridden crop and climate change? This exact question Krishnan was trying to answer in his piece of work on crop-pest relationship. His team wanted to know how exactly climate change would affect Sesamia infestia in major Indian crops and how that would reflect total yield in the future. Therefore, his team created a combinational stimulation model that was strict in its nature and spanned across more than 30 years, embedding different temperature criteria. On the bottom right, you can see that total pest-induced yield loss was greatly reduced at higher temperatures. On the top right, up to the 3 degrees change, yield losses became almost identical to those of the uninfected population. How come? To compose his model, Krishnan worked with as inference on its maturation and development himself, using current New Delhi conditions, and then inserted the data into the three computational models that were available in the past to make sense of as inference population kinetics for each category being studied. Logan model provided an optimum temperature for development which Krishnan used alongside the threshold data in the as inference population dynamic stimulation. To the right, you can see a simplified presentation of above-mentioned computational model the team had to use to obtain usable values for the stimulation and how the data look like post-elucidation. To make sense for the simulation, the team introduced parameters such as adult longevity, sex ratio, and biotic-abiotic mortality rates that can influence population dynamics, with data being categorized previously using the threshold kinetics models and the population model now being written down with the proper parameters. Krishnan derived temperature-linked interval of an S-interference development that you can see to the left. It is evident that Sesamia proliferated better at 33 degrees plus or minus Celsius but started to decline in survivability further on. This information gave the team an insight into how exactly rising or declining temperature would affect population growth. To be able to tell how exactly climate change would affect pest-induced yield loss of the specific crops, Krishnan coupled his current dynamics model to an info-crop rise model and elucidated how rising temperature will affect as interference development and mortality. Coupling with InfoCrop gave him an advantage in having numbers pertaining to a specific crop of choice, because it's provided temperature-related yield losses of uninfected crop population. This allowed him to quantify the effects of sesame on any given crop, with rice being chosen for the study. Moving forward, in this next slide, I want to show you the interpreting the trends of the crops. Quite unsurprisingly, Krishnanand found out that better yield were due to sesame interference crossing its optimum temperature maximum and thus be less suitable for survival under a new habitat. You can see on a bottom right, left and top right that all development population of S interference have decreased and that egg motility became greater alongside with concurrent fertility decreased. Rising temperatures ended up having a direct negative influence on parasite population development. Moving forward to the next slide, where it shows the relationship between the pest, crop, and climate change. Talking about the Krishnan and his work, unfortunately, the team simulation also found that rice won't be able to proliferate properly under high ambient temperatures, assuming present New Delhi condition would take place. It was found that CO2 level didn't affect the S inference, but it isn't clear from the study if CO2 was the culprit behind rising temperature or if the temperature was increasing CO2. Because crop seems to not have responded well to short-term rising of carbon dioxide despite speculated carbon dioxide fertilization. The issue of CO2 fertilization remains its drawback. Looking back at how rice and corn responded to higher temperatures or rising CO2 level in the past. However, this is not the main drawback of this paper. Instead, it is the nature of the crop. Couple model use real-life cases of infestation and the resulting crop yield from New Delhi in the past years. But Krishnan did not take into account the identity of the crop nor their nature. The study doesn't tell us what species were used. This is this is important because efficiency might depend on gene expression under different climatic conditions. It is also unknown if these crops were genetically modified, and this is a big because they are often modified to such a degree that they are able to resist pests or endure harsh climatic conditions. In general, few things are left unknown and need to be addressed. Moving forward to the next slide. Despite present issue, the work has its focal points. Krishnan actually relied on his own generated data instead of relying on previously supplied research that is often outdated. More finically and the data tweaked can be allowed under such model due to this property without getting into a huge bias territory. To date, it seems like Krishnanand coupled model actually stand a chance to be used for good in his underdeveloped world of crop-pest relationship, where nobody focused on primary effects of climate change. But personally, it offers yet simply unbiased data that can be used by both sides of the climate change debate. Okay, friends, moving to the last part of my presentation. In essence, the research study tells us that climate change would probably create a new niche where present pest population won't be able to proliferate as effectively and the total yield lost, at least under New Delhi condition, was strictly due to temperature. It is possible that we might see a long-term rise in productivity of most adaptable food crops such as rice and corn, considering predicted effects of CO2 fertilization, reduced pest survival, and climate tolerance to the crops. Lastly, I want to share my references which I used for composing this presentation, and I dearly hope all of you enjoyed and thought about the material presented. If anything remains unclear, then I will be happy to answer your questions. Thank you, friends. Stay safe. Enjoy.